we're going to kick off now. So just very quickly, just to introduce myself, Dan Stillwell, and my colleague Mark Jones. We are both architects working for Microsoft, and we very much focus on the data and AI space in that respect. So very much OLTPs, the SQL Server systems, all the way up to Azure data analytics in that respect there as well. So today we want to spend the next 25, 30 minutes very much focused on SQL Server. And that's always an interesting one being at a big data event. So I think it's really interesting the evolution of SQL Server through the last few generations and really how now we've encapsulated the big data world in that respect. So we really want to focus on SQL Server and how we really are opening up the world of big data. So I think in regards of big data and with SQL, really we have a couple of things. We have opportunities and we have challenges in that respect as well. You know, and some of these quotes here are just really highlighting some of the challenges that we have, especially in regards of business leaders, the difficulties they have with building analytics over their data sets, but also, and you can't quite see the quote at the bottom, but also the opportunity, which is actually from the Microsoft CEO himself, which says 85% of the world's data is kind of unexplored in that respect. So huge opportunities there to effectively gain competitive advantage for an organization and to really kind of bring the silos together in regards to big data and more traditional data there as well. So as you mentioned, the data challenges now. So generally in most organizations, these are the two major challenges that we see on our day job. Firstly, the inception of big data and how it, particularly over the last 10 to 12 years, how that's exploded in regards to the scene. We've all heard about the statistics and the stats about the world's data doubling in size over the next 2 to 3 years, etc. But then we have the other side of the organization's data, which is more traditional, line of business applications, your OLTPs, your data warehouses. And the challenge really is how do we start to bring these two data sets together to effectively add to the business insights which drives forward an organization. So then we have SQL Server 2019. So we made the announcement last Monday at our Ignite conference in the US. So SQL Server 2019 is now GA. And some of the key things around SQL Server 2019 is closing them two silos. So how effectively we're bringing and bridging the gap between OLTP, traditional systems, data warehouse systems, and the big world data in that respect there as well. And we do it through three things predominantly. And I actually called it the three I's. So it's integration, it's insights, and it's the interface in that respect there as well. So firstly, the integration side of it. So one of the biggest challenges I have is, as a SQL Server DBA or as an SSIS developer, is how do I move data around my organization? How do I shape that data? How do I put it into one place where effectively I can then run queries or run analytics on top of that? The challenge with ETL is the challenge of taking time to move that data around, and not to mention the cost sometimes of moving that data around in that respect there as well. So wouldn't it be great if we had something called Data Virtualisation, that layer above it, which effectively then feeds down to whatever data source that you want to interact and integrate with in that respect. The second key advantage of 2019 is the ability now, as I said, is the interface. So whether I am a Spark developer, whether I'm happy writing Spark, Scala, R, Python, or whether I want to use traditional T-SQL, then actually I need an interface, and I want an interface that supports the languages, which enables myself to do that task in that respect there as well. And again, when we're talking about 2019, what we talk about here is whatever language I use, I can go through a common interface through Management Studio, through Data Studio, through Azure, and I can effectively run notebooks on Jupyter, or I can run just T-SQL, and effectively I can then interact with my data underneath. And that data underneath now is in an interface which is easy to consume, be it as a developer, be it as a DBA, be it as an end user in that respect. And again, what we're talking about here in regards of that interface is the ability to interact with SQL, to Spark, but also to a HDFS as well. And then lastly, it's the insights. So we've got all of this virtualization of data, integration of data, this interface, but now the challenge is how now do we apply and how do we give insights over the top of that data? So what we really want to achieve there is the ability to run the built-in machine learning services that we've had in SQL Server since 2016. So in 2016, we had the R edition. 2017, we had R and Python. And now we've improved that further so that we're effectively bringing all of these big data sets together, and we can run our machine learning services over the top of it in that respect. So what I just want to hit upon now is a traditional challenge that we see in the workplace. So I'm in an organization and I've infested all of my data through many, many different systems in that respect, whether they are OLTP-based systems, whether they are non-SQL-based systems, whether they're traditional HDFS-based systems in that respect. So the challenge is, how do I report, how do I query upon all of these different systems? And traditionally, it's very difficult. You know, again, we can build SSIS, we can build ETL pipelines, we can achieve that. But actually, you know, it's very difficult. It can take time, it can take money, and actually, ingesting data could be difficult in regards of real-time perspective as well. So just to bring this to life a little bit, I'm just going to move. I'm going to do that. Just to bring this to life a little bit further, what I've done now is I've created a Power BI dashboard. And this dashboard here is a way that I can ingest data from many different sources. You know, Power BI is a fantastic tool. We can integrate with data across almost 100 different data sources in that respect, whether that's SAP, whether that's Oracle, whether that's Teradata, et cetera, et cetera, et cetera. You know, but this is a common challenge. As a business owner, as a business platform owner, I want to see, for example, my retail organization, I want to be able to see clickstream data, who's clicking on my website. I want to analyze that data that's been ingested into an HDFS. I then want to align that with my more metadata, which is based in SQL Server, so my customer-based data, et cetera, et cetera. And then I want to align that with my Oracle data, which is my inventory-based data in that respect there as well. Now, again, from a Power BI perspective, you know, I can connect to all of them different data sets, and that works absolutely beautifully. So again, I can click on my music category, and I get an understanding here, you know, what stock I have in warehouses, what invoices I get per category in that respect there as well. And again, that's integrating data from an Oracle system, from a SQL system, and from an HDFS system as well in that respect. The disadvantage, though, with that is, as a person who may be developing this Power BI dashboard and who requires self-service, they then need to have a connection string and authentication to all of these different data sources as well, which again is a governance and security challenge in some organizations. The fantastic thing here is, actually what I'm doing here is I am actually connecting, and if I show you my data source connections, when it fires up, I'm connecting to one data source here to achieve this. And just to prove actually that I'm not cheating, I actually will show you the fields as well. So I can see here I've got my clickstream data, which is based on HDFS. I've got inventory data, which is based on my Oracle system. And then I have item and I have warehouse data, which is based within my SQL Server system in that respect there as well. So the key point there is I now am in a position where effectively from a Power BI, from an application, from a report perspective, I can connect into now SQL Server, the master point of it, and I can effectively consume all of that data wherever it may sit within my own organization or even a sister company of mine in that respect there as well. So just to finish off the slide at this particular perspective, all I've done from a Power BI perspective is connect directly into SQL Server. SQL Server is taking the effect and basically taking the virtualization to a perspective where now it's connecting to my Oracle system, to my HDFS, and to my SQL Server system in that respect there as well. I'm now going to pass it over to Mark, who's now going to go into detail about the architecture and how that works.
Hi everyone, just a minute to make sure this is working as well, thank you. So, as a SQL guy, historically, or if you're a big data person in this audience as well, you might be just kind of asking yourself, hang on a sec, what is this thing? What are we doing here? And before I take you into how we built that dashboard in the back end and using the big SQL cluster to build that back end, I thought what would be good to do is just quickly cover off some of the basic concepts of the architecture of a big data cluster. And so what you see up on the screen at the moment is the interface between our business, our Power BI dashboard is made through what we call a SQL Server mastered instance. And imagine this is your control node. So this is just a SQL Server at the end of the day. It's just regular SQL, and I'll show you that in a second. But what that SQL Server has behind it, stored within the Kubernetes cluster, is a distributed pattern for a compute plane, which is, again, SQL servers, but distributed. So we get the power of scale into this platform. Underneath that compute plane, we have two storage planes available within the big data cluster. So the first of those is our HDFS. Now what HDFS is built on top, and what we've done to actually interface with HDFS is built on top of that two headers. One of those is Spark, and one of those is SQL Server. And actually, SQL Server now natively can talk to HDFS if it's in a CSV or a Parquet format. Alongside that, sometimes we want to be pulling that data in to, and exploring that data within our big data cluster, but we also want to be able to persist some data. We want to be able to build out our data marts. And so alongside our compute layer, we have a SQL Server data pool, which is a sharded, distributed platform for storing data. Now this is, like I said, this is all controlled from the master instance. So basically that's where you interface to. SQL Server and the big data cluster takes care of the rest of this, okay? Now, the data virtualization that we just seen there, I'm just going to flip over to a demo environment, and I did put a little note on here. This is a baby demo, okay? I know this is a big data conference, but we've got a very small server to be working with at the moment. So I'm just going to flip over to that, and I'm going to show you a few things. Hopefully this is coming up on there as well. So apologies for the resolution on this, but hopefully you can bear with. So the first tool that I want to show you is Azure Data Studio. So this is a new platform, a tool that you can deploy onto your VMs, and it will connect, and it has intelligence about what a big SQL data cluster is, okay? It has a number of extensions, and you can use it for things like Postgres as well. Very, very cool tool. If you haven't used it, I suggest you have a download and play around with it. So what we've got here is I've connected to our master instance of the big data cluster. And this is just regular SQL. It's got databases have tables store data, okay? But alongside this, what we now have is the native inbuilt capability. So I don't have to worry about installing drivers or anything like that. But now I can connect to an Oracle system within my network I have line of sight of, and pull that data in and explore that data as part of just using this big data environment. And so this is a query I've run here. I'm not going to run it again now, but I'm just going to break down exactly how we constructed this. So this is using Polybase to connect to that Oracle system. Now Polybase has been around for some time. It's extremely performant and extremely efficient. So what we need to do to help build this for Polybase is to tell Polybase exactly where a set of credentials to connect to the Oracle server, where that Oracle server lives, and then essentially tell SQL Server to create pretty much a view or a table that's empty, but it's got the predicates in there to push this query down to the Oracle server at runtime. So when I run this query, it's actually going off to that Oracle server and pulling that data in. I don't need to worry about ETL. This is all set up for me. Okay, so that gives us, for that report that Dan was showing, this is getting a live feed of our inventory data. But the second part of the report that we need to run, and I'm just going to kick this off now because we do have a baby cluster. The second part of this is that we need to connect to HDFS. Now within this big data cluster, we have a HDFS capability, and that you can see through this, this interface here. So within this HDFS cluster, so this HDFS file system, we have a number of CSVs, and there's about 30 million rows in there, so quite small, but big enough for this environment. And so what this stores is clickstream information, and we just want to interface that. And if you can see, and it's very small, apologies, but if you can see right here, we are actually joining that clickstream data live with data that's stored within the sales database itself. So we've got a single statement that's going off to HDFS, pulling back information through that folder structure, and find it and joining that with live SQL data that's stored within our data warehouse. Okay, so that's going to take a bit of time to run, but if I just scroll up, just to show you how this is constructed, again, we're telling Polybase the file format that we're looking at. So this is CSV files this time. Then we're telling it where to go, and this is the SQL Server storage pool, it's the HDFS cluster. And then we are creating that empty container to say that this is the kind of structure that we want, deal with it like a SQL table, and that enables us to do this interactive join between what's stored within SQL and actually what's stored within HDFS. And as you can see, this comes back with a nice set of information that we can use in our reports. But that took quite a long time to run, and there's quite a lot of low-level data that we're trawling through there. So the last query that I wanted to show quickly was how to use the data pool. So this is our ability to store this data now in a distributed fashion on our big data cluster. So the same principle applies, that we are connecting essentially with Polybase to an external data store. We're creating an empty table for this. Once we've created that empty table, we're going to insert into that the data from HDFS. Once we've done that, and we've done a little bit of cleansing on the way, we can now run this same query and get the same results from our data pool, but because now this is using distributed fashion and we've got a slight bit of optimization in this, we can get the same results in a few seconds. Okay? Now this, just to replay that, we're now joining data within our warehouse, within SQL Server, joining data within Oracle, and joining data within HDFS or within TSQL. Now, if you wanted to create these external tables, there are some wizards that you can start to use for this that are starting to be lit up within the Azure Data Studio. For example, I could create an Oracle external table, and this wizard would start to walk you through what you need to create that external table. Okay? Secondly, we've not really touched on it too much, but we also have the ability to explore this data through notebooks. And I think I've got one notebook open somewhere, probably not, no. But what I can do is actually click on this data that's actually stored within HDFS and analyze that in a notebook. So SQL Server Data Studio and the Big Data Cluster has a Knox gateway in there. So you can run your interactive notebooks as part of this environment as well. And actually, we support all the major kernels, and also we've introduced a new one, which is SQL. And that means you can actually run your SQL statements, like you would do Transact SQL, against your Big Data Cluster, but using that SQL kernel instead of PySpark. So you've got full flexibility and quite an extensible amount of language there. Last thing I wanted to show you is once we are in our big data cluster, we need to be able to monitor this and have a look at what's going in. We've probably got some performance tuning, etc. So what Microsoft have done is we worked very hard on creating a number of dashboards that are available, built on Kibana and Grafana, as well as some of our own dashboards as well. And so I'm just going to step you through a couple of these. So the first dashboard that I'm going to step you through, this is our host node, and this is fantastic because it gives you all the information about the environment. You can configure this as you want, you can export it as you want, but it gives you information about actually physically at the node level what's happening with our server. Next to that, we've built a SQL Server dashboard, and this gives you all of the information that you would expect to see from a SQL Server, what my weight stats are, what my memory allocations are like, etc., etc. And then lastly, we've got our logs alongside this, which is fully searchable Kibana logs. You can ingest those and do what you like with that. So hopefully that's given you a bit of an overview of what a big data cluster is. I'm just going to wrap up by saying, if you have HDFS implementations already, you've got something in S3, you've got something in Azure, actually the big data cluster can consume that data as well. So you can actually mount your big data pools as they stand in your existing S3 buckets and pull those into this environment as well. Next to that, we've got an application pool built within this big cluster. So if you've got ML machine learning models, you've trained your data, we've built the data mart, we're training models, you can actually deploy them within this app pool as well. Next to that as well is also stood up SSIS. So if you have SSIS packages that you do want to run, you can actually lift these into this big data cluster as well. It fully integrates with Active Directory and has high availability for those endpoints where it's needed. So for example, that master instance endpoint has high availability built into that, but all of this is simply wrapped around in a Kubernetes cluster. And so this gives you the power to deploy this where you like. You can deploy this on premise, you can deploy this in Azure in an AKS cluster, you can deploy this in AWS. It's fully extensible. Anywhere that can run Kubernetes, you can run this clusters. So just to wrap up, gone through very fast, and apologies on the time, we didn't have a lot of time today, but we've gone through one of the major components of SQL Server 2019. There is a lot more in SQL Server 2019 that we can talk about. We're just in the pods just outside the door here. So for myself and Dan, we'd just like to say thank you very much. And if you've got any questions, come and find us. We'll be there for the next hour or two outside the door. So thanks, everyone. And if you want to follow some of the demos that we just did, AKA BDC clusters, that should take you to where you need to go, but we'll leave these links up for the time being. Hopefully that's okay. Thanks, everyone.